Good morning. Let us continue by doing more work on graphs, CIE, physics, kinematics graph. Question 1. The diagram shows a velocity time graph. What is the displacement during the last 2 seconds of the motion? Last 2 seconds would be the time from the second to the fourth second. So this is a trapezium. 6 plus 12 times 2 equals 18. That's the answer. Which displacement time graph best represents the motion of a falling sphere? Its initial acceleration of which eventually reduces until it begins to travel at constant terminal velocity. Constant terminal velocity will give a constant velocity. This is the displacement time graph. At the end, it will be a straight line. The answer is D. The gradient is decreasing, meaning the gradient is increasing, meaning the velocity is increasing. A ball is released from rest above a horizontal surface and bounces several times. The graph shows how, for this ball, the quantity y varies with time. What is the quantity y? Obviously, it looks like a ball bouncing. So if you use the displacement going down as positive, this would be a good representation of the displacement. Displacement to the floor is this height. Okay. You will see that the gradient is changing, means the velocity is changing. When a driver sees a hazard, she applies the brakes as soon as she can and brings the car to rest. Graph shows how the speed v of the car varies with time t after she sees the hazard. Which graph represents the variation of time t of the distance s traveled by the car after she has seen the hazard? You can see initially before she brakes, there's a constant velocity. Therefore, the line must be a straight line. And here, the velocity is decreasing, gradient will be decreasing. And the answer is C. The velocity time graph below is for stone thrown vertically up into the air. Air resistance is negligible. The stone is thrown up at time 0. Area x represents a distance of 5 meters. Area y represents a distance of 3 meters. What is the displacement of the stone for its initial position at time t? Area above the graph gives a positive displacement. Area below graph gives a negative displacement. So this is 5 minus 3 gives you 2 meters. A small steel ball falls freely under gravity after being released from rest. Which graph best represents the variation of the height h of the ball with time t? Height of the ball with freely under gravity. So you would be velocity is increasing. Which graph shows an increasing velocity from a certain height? So the gradient here is increasing, but increasing with a negative value. A football is dropped from the top of a 3-story building. It falls through air until it reaches the ground. What remains constant throughout the fall? So it falls through air. Huh? So the weight of the football would be constant. Air resistance will be increasing. Acceleration of the football will be decreasing. Velocity of the ball will be increasing. A student throws a ball in the positive direction vertically upwards. The ball makes an elastic collision with the ceiling, rebounds, and accelerates back to the student's hand in time of 1.2 seconds. Which graph best represents the acceleration of the ball from the moment it leaves the hand to the instant just before it returns to the hand? Here, positive direction is upwards, acceleration downwards, acceleration of free fall is downwards, and is negative. So these two is the possible solution. The other clue is there's an elastic collision. That means it rebounds back with the same velocity or same speed. Therefore, the time it goes up and time comes down is the same. So it will be D. So you may want to explain this. The acceleration, the value of the acceleration increases, or the magnitude of the acceleration increases when it hits the ceiling. There's an additional force beside the weight that is pushing the ball, which explains an increasing resultant force, therefore an increasing magnitude of acceleration. The graph shows how the acceleration of an object moving in a straight line varies with time. The graph shows the variation with time of the velocity of the object. Okay. The acceleration is always positive. Therefore, the velocity is always positive. There's one A, B, and D is possible. But you can see that the acceleration is increasing here and decreasing here. So the gradient must be increasing, then decreasing with a maximum gradient here. Maximum gradient. So this here, the gradient at middle is 0. So this is out. This is an increasing gradient. So answer is A. A ball is released from rest at time 0. After 1 second, it bounces elastically from a horizontal surface and rebounds, reaching the top of the first bounce after 1.5 seconds. What is the total displacement of the ball from its original position after 1.5 seconds? Again, the same positive displacement. This is 5. This is 1.25. So it's minus 3.75 is the answer. A particle moves in the manner shown by the velocity time graph. The displacement of the particle has been measured so that it is 0 at time t equals 0. Point Q refers to a point in its motion. Which row of the table is correct? Time for maximum displacement. So the maximum displacement is either at 5 or 10 seconds. That is when the velocity becomes 0. You get a maximum displacement. So the answer is either B or D. Acceleration at point Q, gradient is 0. Answer is D. The gradient of a velocity time graph is its acceleration. A tennis ball falls freely in air from the top of a tall building. Which graph best represents the variation distance s fallen with time t? Again, terminal velocity gives a straight line. Increasing gradient followed by a straight line is A. A small glider, now let's jump to the next question. The velocity of an object during the first 5 seconds of its motion is shown on the graph. What is the distance traveled by the object at this time? Area under the graph. Half times 20 times 5, which gives you 50. Okay, a ball is released from rest on a smooth slope X. It moves down the slope along a smooth horizontal surface XY and rebounds inelastically at Z. inelastically, and then it moves back to y and comes to rest automatically somewhere on xy. Which velocity time graph best represents the motion? Okay, so first part of the graph, all is the same. So the second part of the graph, this part of the graph, and this part of the graph must be of equal area because they are of equal distance. Huh? So only these two gives you this answer. This is moving from y to z and z back to y. Now when it moves back up the slope, the gradient must be the same as the acceleration is the same. So A only gives you the answer. Which feature of graph allows acceleration to be determined? The slope of Earth velocity time graph. Okay, we will stop here and continue with our part 2 later. Thank you. If you like and you want updates, more questions and answers, subscribe to this channel. You will get more. Bye.